learned the general characteristics allowing a text to be machine readable, you may be asking yourself how all the pieces of information not contained in a plain text, such as a character font, text formats, and file structure, are stored and processed. Hence, in this introductory section, I'm going to present basic concepts about file formats and markup languages, because these two aspects affect the way we process and analyze texts, as well as the way in which we can manage and reuse textual data. A file format is essentially the way data is structured and saved in a file, determining how it can be accessed and read by software. A file format specifies how bits are used to encode information digitally. Broadly speaking, file formats can be categorized according to their use and the type of information they store. For example, an archiving file format like zip is used to store file collections or folders into a single file. Audio formats like WAV store audio information, and so forth. Here, however, we are especially interested in document file formats, which are used to store texts and their properties. File formats may be either proprietary or open. Proprietary file formats, developed and owned by specific companies, include formats like PSD, Adobe Photoshop, and Pages by Apple. These formats offer advanced specialized features. However, due to their closed nature, potentially limiting accessibility and long-term preservation, they can restrict interoperability, as they may not preserve all their characteristics when accessed through other software. This is a key issue when talking about data management, processing and storage. We will discuss these topics in more detail when introducing FAIR and open science principles. Conversely, open file formats such as TXT, CSV, HTML, and ODT, which means Open Document Text, are publicly documented standards, accessible to anyone without restrictions. Open formats support interoperability, long-term preservation, and facilitate collaboration and data exchange across different platforms and tools. These text file formats can be used to encode either plain text or rich text. Plain text formats like TXT are used to store textual information without formatting, making them easily readable across different software and very light and portable. As you may have already understood by now, plain text is ideal for linguistic analysis, as long as the bare text is enough for your purposes. Formatted text formats, also known as rich formats like docx, on the other hand, allow you to include additional formatting information like fonts, images, and layout. While visually appealing, their internal complexity complicates textual extraction and analysis. Additionally, rich text formats are typically larger in file size compared to plain text, potentially impacting storage requirements and processing efficiency. In most cases, it is however possible to extract text from rich files. It is also possible to extract text from images thanks to the optical character recognition technique, also known as OCR, that we'll explore in more detail when talking about text collection and extraction in the next unit. Formats like CSV, comma-separated values, or JSON, JavaScript object notation, are maybe less common in everyday use, but are instead preferred by researchers working with data because of their structured nature that makes them very easy to process by computers. These formats are light-weighted. They are supported by many software and applications. For example, they can be used in Python and R codes, and they allow to present annotations and structural information near the relevant text portion. Moreover, information about style, formatting, content, and structure can be preserved in plain text formats through the use of markup languages. A markup language is a system for encoding document structure, contents, and appearance. As a matter of fact, markup languages can be structural, semantic, or presentational, depending on whether they carry information about the structure of the document, its content, or visual appearance. In markup languages, information is expressed through tags. While some markup languages like XML allow you to create tags according to the type of information you're adding to your text, it is always advisable to refer to existing tag and annotation systems to reduce ambiguity and enhance data reusability. But what are tags? You can think of tags as labels. Every tag has a specific format. In HTML and XML, they are enclosed in angle brackets. Inside the brackets, you find the name of the element that is described, for example, title or paragraph or speaker. This element can be followed by an equal sign and an attribute, which gives information like title equal lesson 1 or speaker equal Chiara. Historically, both HTML and XML developed from SGML, Standard Generalized Markup Language, the difference being that HTML is used for web publishing, representing web contents in standard formats for interchange, while XML provides a syntax that can be employed for a much wider range of uses, when exchanging structured data of many kinds. The Text Encoding Initiative, TEI, which we will treat in greater detail at the end of the module, developed standards for markup within digital humanities based on XML, enhancing textual preservation as well as data analysis and resource reuse. To sum up, we can say that choosing appropriate file formats and markup languages involves balancing distinct advantages and challenges related to ease of access, sophistication, file size, standardization, and interoperability. You will learn more about differences between plain and rich text, as well as about the main types of markup languages in the following sections. For now, just keep in mind that understanding file formats and markup languages is fundamental in corpus linguistics and digital text processing, directly impacting analytical quality, efficiency, and scope. When dealing with text processing, learning to select the right file format for your project and to use markup languages appropriately are key skills, guaranteeing interoperability and data longevity, and ensuring that corpus materials remain accessible and reusable across platforms and analytical tools.